Dear students, we must understand now we have gone to grade 11 and now there is a particular method, a different method for every subject. Let's recall in the earlier classes, let's say 7th, 8th, 9th, 10th, there used to be classes, some notes by the teachers, some book exercises, some assignments by the schools, by the teacher. You do them, you give exam, you give the test, you score well, you are happy, everybody happy. But as we go for grade 11 and 12, now it is going to be the importance in the professional entrance examinations, or you are on the verge of going to professional college after 11th and 12th. So time is the same for every student. Only thing is you must understand the methodology of every subject. And since I am teaching mathematics and physics, I will talk of the four so-called scientific subjects, which are biology, chemistry, mathematics, and physics. And then you will understand what is my methodology. See, when we study about biology, it is stated that you have to learn the subject. What is in biology? The human biology, the size of the heart, the diagram of the heart, the pumping of the blood, the liver diagram, etc., etc. Functioning of liver, functioning of eyes, nose, and all. Now, this aspect has not changed for the years together. 500 years back also the man was listening through his ears, seeing through his eyes, and today the same. 500 years back also the person was having a red blood. Today you know the various components of the blood, plasma, RBC, WBC, and so on. So fundamentally there is not much change in biology. So it is rightly stated to be a subject of learning. We have got a particular size of the heart, diagram of the heart, diagram of the liver, etc., and so on. If there is some change in the diagram of the heart of any particular person, we say there is some illness, so we should rectify it. So basically, there is some standard things which are there, which we should keep in mind. So that's why the subject of chemistry is for learning. Now we talk about the subject of chemistry. Now chemistry also you have to take lots of things for granted. When you are listening to this video, you are viewing this video, you are obviously going to be in some area, whether room or outside. But over there, you know the oxygen content is roughly 20%, nitrogen is roughly 80% in the atmosphere. But how do you know? How do you measure? Since you have studied in the previous classes, you have to take it for granted. You will require a typical gadget or a device to find it. Somebody says it is oxygen and nitrogen. How do you prove it is O2 and N2? Now you cannot prove unless you use some other devices, some other chemical reactions to prove it. That's why chemistry also, you have to take it because you cannot see the molecule. What you study in chemistry, the molecules, their bondings, and the molecule and bonding, atomic structure, etc. So atomic structure for any atom is very, very small, 10 to the power minus 15, minus 16 is the radius. Mass wise 10 to the power minus 27 kgs. How can you see such material? That's why whatever somebody has stated, you have to accept it, okay, unless somebody else proves it wrong. And that's why if you remember, for the atomic structure, we had some Dalton model, Thomson model, Rutherford model, Niels Bohr model. Why? Because everybody carried out certain experiments, found the observations, and gave something about the atomic structure. The other persons raised some doubts which were not being satisfied by that theory, so he gave some other concept and he gave one more theory. And this is what is happening till date. Niels Bohr's atomic model also we say is for hydrogen type atoms. For more atoms, we have still not taken any final thing for the atoms. So this is about the chemistry also you have to learn. But now let's talk of the mathematics. What is the mathematics? Mathematics is basically, we call it a tool. See, in the lower classes, you have studied trigonometry. Sine theta, cos theta, tan theta. But first time when you use sine, cos, tan in some heights, distances problem, that is the first time it came into your mind, oh, it could be helpful to find the height of a tree, height of a mountain, or the length of the river, or any other thing. So it is a tool. And what is a tool? It's a gadget in layman's language to do certain work. Who can perform the tool very well? The only one who uses the tool. That is why mathematics is said to be a subject of practice. If you see your kitchen, whosoever is making the food, there is bound to be 3, 4, 5 knives in the kitchen. We all know theoretically one side of the knife is blunt, another is sharp. But which side to use on what, which is blunt, which is sharp, that is only the person who is using can tell you better. And which knife to use for which purpose, for which vegetable, that is only the person who uses can tell you better. That's why we say tool is something for which you have to practice much. And that is why mathematics is the subject for practice. The more you practice, easier for you to attempt the question. So remember, practice is very important in mathematics. There will be simple formulas. I mean, the formulas for the mathematics are limited, but the application part is very, very vast. So for the application part, you must understand which formula to use and how to use it. Lastly, I come to the subject of physics. Do you know what is the meaning of physics? Physics, in fact, is not an English word. So, it could be Greek or Latin. The word physics means nature. And remember what you study in physics? Heat, light, sound, electricity, magnetism. Everything is already in the nature. So basically we are studying nature. So to study the nature, remember, if you observe the nature and the other experiments closely to you, it will be easier for you to understand. Let me give you an example. We all have studied a word called inertia, which says it's a property by virtue of which body resists change in motion. Okay. Even if to a layman, if you bring a truck and a car and you say you have to push it, in which you require more force, so layman will also say truck because he is seeing the truck is a larger body. By the physics principle, you will say larger mass, larger inertia, Newton's law, F is equal to ma, more force because of more inertia and blah blah. But even layman knows it. A bigger body has got more inertia. That's why in physics the experiments have got very important. That what is the experiment which led to that conclusion? We all know the Newton's gravitation law. It was somewhere in 16th century. Can we ever say that prior to 16th century apples were not falling on the ground? No, they were falling. He observed it. So only difference was he observed it, the natural phenomena, and then he gave the result of it. Similarly, once upon a time a student asked me, sir, electricity was developed 200 years back. I said, no dear, the lightening of the clouds is there in the nature from the very starting. So, lightning is there. You are using that electricity now. That is a separate story. So that's why the experiments do carry very vital role in physics. So when I teach student of physics, I always insist what experiment. And secondly, I tell the students to see the nature, the things around you. If you see a thing around you, supposing I tell you, okay, go push a car and a truck, and then let's discuss inertia, it will be easier for you to discuss inertia because you have already felt the inertia. That is the difference. So any experiment, you rub your hands like this, fastly, then slowly. Fastly, you get slightly heat in your hand. Why? Because you are developing the heat very faster. If you see this experiment, you can understand that heat flows off, heat goes to surrounding in certain time. If prior to that time you are giving more heat to your hand, it will get heated up. Similarly, lot of small experiments which you see close to you, you will be understanding physics very well. In my classes, I always appreciate students with doubts. I always try to make my classes more interactive. That's why I don't go for a very large group of classes. I mean, students in a group, very small batches, preferably 1 or 2 only, or 3. Because then we discuss. Important thing in physics is discussing. Secondly, people have a problem in numericals. Let's analyze. If you do a numerical and you get some answer which is wrong, then you use another formula and you get the correct answer. You might think that you have known the question, but according to me, you have not known the question until and unless you discuss why the first formula which you used is not to be used. If you are very clear why this formula is not being used, then of course you have understood the question. So this is the way which I talk of the teaching in physics, mathematics. All the best to my students. If you require any guidance from me, I'm always there. I have always been teaching after doing my IIT graduation. For the last 28 years, I have been teaching, and I always encourage students to raise doubts. So you raise doubt, ask the question, and that's how we proceed for the better knowledge. Thank you.